Hello and welcome back to another cringy video by yours truly. Today I want to talk about how I recreated one of my video games, Bridges and Docks, in a completely new game engine. And no, it wasn't because I needed to do this, I just got way too good at using Unity and I needed a little bit of a challenge. But on a serious note, I know that around this time of year, people are shopping around for game engines because a lot of people are getting into game development for the first time, setting New Year's resolutions, trying to start to dabble in what game development actually is, how does it work, what kind of game engine should I adopt, all of that good stuff. And so I thought this would be a good time to look around and see what the landscape has as far as new game engines. I have heard a similar sentiment from a lot of developers that there are many of you who eventually want to go on to create a game engine for themselves, which I think is really cool and admirable, and I have good news for you, but we'll circle back to that. Before we get into all the game engine stuff, I want to explain to you what my game Bridges and Docks is all about. So this is my game Bridges and Docks, and the cool thing here is that you're just staring at water, and that's how the game starts. You can do some cool stuff like add some different tiles and like do this and start building. You can go to the erase tool, which is over here, and you can start deleting stuff, add some trees and do all this, and then you can add some grass, rocks, some like big rocks over here. Bridges, the cool thing is that you can build bridges and docks, believe it or not. So you can kind of make these cool little island environments, and you can change like the brush size, and you can add stuff over here and then over here and then over here, and then you can add little animals, and this could be like a little sheep place, and then maybe we can add like a little house for the shepherd to hang out on. There you go, that's where I would want to live. Have like some cliffs behind him that can kind of be his little safeguard against the elements, you know what I mean? So maybe we'll go around here and we'll just make a little area for him to be protected, a little cove. Okay. This is turning into more of a Bob Ross video. Distractions over. The reason that I brought you here today is because I want to show you what you can do with this tool right here, which says procedural generation. When you select that tool, you can hit the generate button and it will generate an island for you. You can mess with all of these different sliders. So like the width and the length, like you can have like a really skinny long island like this. I can go to the height over here and make it like really tall. And so this is so fun to play with because you can just make like these big island environments, big massive dramatic cliffs, super fun to play with. Or you can make the land like very low variability, so then it's a much more gradual sort of change in the terrain. Really cool tool because you have all of these things that you can mess with. This is Bridges and Docks. This is way longer of an intro than I thought I was going to be doing for this game. But it is really fun to play with. So then this is really fun because then you get like a few little islands, and then you can start adding your own custom stuff. Like maybe I want one in here that's just like, get on with it! So let's get into the game engine stuff. So I recently came across this browser-based game engine called Lemonate. So I thought this engine looked really cool, and I reached out to the company who develops this game engine to see if they would want to do a collaboration. They were all for it. So thank you, Lemonate, for sponsoring this video. And I'll give you guys some more stuff about how you can get plugged in with this platform later on. So before we can jump into using this cloud browser-based game engine to remake my game Bridges and Docks, we have to go over something kind of important, and it's called Perlin noise. Basically, you can think of this image as being values from 0 to 1. 0 is black, 1 is white. But what's cool about the Perlin noise algorithm is that it takes values of a coordinate system and it gives you a single value from 0 to 1 that is similar to the pixels around it. And so that's why it looks blurry. And that's why you can make things like this, which have very gradual increases or decreases in value, because if you feed in an XZ coordinate, then it gives you a value that you can use for the height, the Y value. And that makes it so that you can make some really cool stuff. Let's just jump into the engine and see if we can build out this project and make the Perlin noise procedural terrain generation tool that I know and love. Okay, so this is what the engine looks like. You start off with a little floor and a cube. Looks relatively familiar. You have like a scene view, some logs, inspector panel where you can start editing stuff with graphics and physics and all of that good stuff. But step number one for starting this procedural generation tool is to spawn a single cube. If we can spawn a cube, that means that we can spawn multiple cubes, and we can spawn multiple cubes wherever we want. Okay, we need to have some real talk here though, because as a developer, when it comes to learning a new technology or a new tool, there are two main options. And the first one is to go and read the documentation and learn how to use this tool or language or whatever the proper way. The second way is to cheat and take somebody else's code. So guess which one I'm gonna do. Can you help me decide which decision is better? That's right! You may be thinking, who am I going to steal this code from? Well, the cool thing about Lemonate is that it is not only a browser-based game engine, it is also a place where you can play games that developers have published on their website. Similar to like itch.io, you are able to just publish your games made in their engine on the browser and play them straight from the browser. But that's not all, because if you take a look at this, you can see all of these games that people have made. But the cool thing is you can play them, or you can come in here, play some Tetris or whatever. But that's not all. You can go down here and hit this remix button. And this remix button will clone this project into your dashboard. And then you can just name it whatever you want. My Tetris now. And bam, just like that, we are ready to start editing. So when I say steal code, this is what I mean. You can literally open up any of these games as your own project. You can start dragging stuff around, making edits. You can see all of their code. And maybe some people watching this video know how to script in Lua. But hey, we can look here and kind of learn and figure out how everything works. Not only can you play the published games, but you can remix them and edit them as your own project, which is super cool. So when I say that I want to spawn a single block for my project, all I have to do is go over here and say, can I find any games where they are spawning a block? Hey, look at this one. Let's figure out how they do it. And it's that easy. If I don't get to 100, I will delete my YouTube channel. Oh no. Oh, he had a good run. You see this? This is a spawned cube. This is what already exists in the scene. There's like this floor, and then there's this cube that you start with. But when I hit play, you see this big rectangular prism? I did that. And if you care about the code, this is what it looks like. And if I hit play, boom, you can see we spawned in a block there. Achievement unlocked. Editor, you can put in a little thing down here that says achievement unlocked. And then when I do that, you should put the achievement actually up here. I spent some time figuring out how to add some color to the scene, blocks spawning in a grid, and then I moved all of the blocks spawning into the update loop so that they can animate in. So now when you hit play, you can see that they spawn in a grid and they can change their colors based off of where they spawn in. And if anybody cares, here's all of the code that I wrote for that. Okay, so spawning cubes in a grid like this is great, but now we need to actually implement the procedural algorithm that will allow us to fluctuate the heights that they spawn in at. Right? Well, here's my problem. Let me show you. So here is my code for bridges and docks written in C# and Unity. And if I look at this is what I want to draw your attention to. mathf.perlin noise. In C# and Unity, there is this library, mathf, that I can use to call a function that does all of the Perlin noise algorithm for me. It's a library that I can lean on, but it turns out I couldn't find anything like that for Lua, so I had to make it myself. So if you look here, I actually made my own Perlin noise class. Basically, all that it does is, this is the algorithm for Perlin noise, but I had to implement it myself. I'm sure that I probably could have found a Lua library that would do this for me, but I didn't want to learn all of the stuff with how you import different packages into a project like this because I am lazy. But basically, here's what I'm doing. I am trying to get a y coordinate based off of the x and z coordinates. And so I'm calling this function getHeight, and I'm just figuring out the x coordinate, the z coordinate, passing that in, getting the height from it, and using that y coordinate to figure out how high the tile should spawn. And so if we hit play, it looks like that, and things are looking pretty good. Okay, so let's pause here and take a little assessment on how we're doing so far. If you take a look at how these blocks are all spawned out, they are able to spawn according to the Perlin noise algorithm. It's starting to take that procedural terrain shape. One of the issues that we have right now is that the blocks are not spawning in heights of increments of 1. Basically, I need these blocks to snap to a certain height. So I don't want them to spawn at like 1.26 Y value. I want them to be able to only spawn at 1 or 2 or 3. You can see here that I can change the grid size. So right now it's a 20 by 20 grid, so like 400 cubes. But if I up that to like 50 by 50, it takes a while to generate, right? I have a variable in here that allows for a certain number of blocks to spawn per frame, because if I just do it all at once, it's just gonna chug. There's a little bit of lag if I try and spawn too many cubes at once, which is something that I want to address next. But I think this is pretty good because we have the entire foundation already built out that will lead to a game like Bridges and Docks. But before we go any further with it, I want to include some of my conversation with one of the developers of Lemonate. I was able to sit down with Chris, who is one of the co-founders and lead developers for this game engine. The first thing that he showed me right out of the gate is how he was making a racing game, and he explained to me how simple it is to just grab a racetrack mesh off of Sketchfab, and he uploaded it into the engine, and automatically he had a racing game that was functional out of the gate. He was able to explain some of the physics engine in depth and why it works the way that it does in this stack. He was actually very eager to get feedback on my experience as well, so I was able to kind of walk him through some of my pain points that I experienced as a new user, and he was taking notes and going to take it back to the team and make changes based off of my experience, which is really cool. One of the most difficult things and it was right at the beginning, was just trying to figure out how to add a script. I watched the YouTube tutorial eventually, and that's how I got it, because I didn't see anything in the docs.
Let me just take notes here.
We were able to go a little deeper into the physics engine that powers Lemonade. We also walked through some of the composition settings in the editor with the ability to add post-processing chains. He showed me how easy it is to use the asset store that they have built into the editor, how you can just search for a mesh and then drag it straight into your project. And all of their stuff is free for commercial use, which is awesome. Then we talked about what it takes to publish the game online, and we talked about the specifics of using Lua as a scripting language for the game engine to utilize, and kind of the drawbacks of that versus JavaScript. One of the main things is that you can actually use a debugger and use breakpoints when you use Lua, so that's one of the main benefits for using that language. I was really impressed by his desire to build a game engine that is very unbloated.
We want to build a simple game engine, not a complex one. I'm not sure if the world needs another complex one. We have a couple of them already. So why build another one?
Him and his team are setting out to make something that isn't necessarily a competitor with Unity or Unreal, but his desire is to make something that developers can use, and it can be lightweight and functional for the community. And then we talked about future plans for the game engine. And the main two things are that they want to make the engine open source, and they want to implement live collaborative editing with teammates. And I was talking to him about some of my optimization techniques that I was using for spawning cubes, and he was recommending my project to use a single mesh instead of all these different cube instances, and then just use the Perlin noise algorithm to generate all of the vertex positions instead of the cubes themselves. I didn't end up implementing that myself, but if any of you do it, let me know. And if you show me your remixed version of this process where you were able to take vertex positions on a single mesh and optimize it, let me know and I'll send you a free key to Bridges and Docks. And then we just ended the call by me basically talking about how much fun I'm having using the game engine. And it's really fun to figure out how they have different implementations for things that I'm used to doing or not used to doing. And it's just been kind of a fun little challenge to see the different ways that game engines are able to operate. And if you're interested in hearing that whole conversation with Chris, I'll upload our full uncut conversation on my Patreon, so you can check it out there. The team was very open to my suggestions in order to make the engine a better experience for everybody. They really care about the product, and they really want feedback from developers. They even added this big feedback button in the top right of the editor. Okay, back to the project. So here you can see I've implemented some object pooling, which is an idea in game development where you spawn all of your objects ahead of time. And so what I did is I took the grid size and I made sure to pre-populate a data structure with all of these blocks, and then I moved them off of screen. And then when I'm ready to use them, I just move them onto the screen at whatever position I want. The idea behind this is that it actually is a lot less expensive for the hardware to be able to move the position of an object than to create a whole new object. So if you look at this, you can tell that it's actually spawning blocks. It takes a little longer to start the application, but then once it starts going, it spawns the blocks a lot quicker because I'm utilizing my own object pooling. And so one of the major things that I knew I had to add into this game was the UI. The user interface for people to come in and click buttons and be able to change configurations so that the terrain that's being generated can be according to their own configs. And so you can see here what I've added in is a button for generating terrain and then clearing the terrain. So you can see it no longer automatically just starts spawning blocks, but you can hit this little button and it boop does it. But what's interesting is that this little tools window for the user interface, it's actually a code library in Lua called image UI. I am used to making user interfaces in Unity where I drag and drop and I graphically set up a user interface. But what's cool about this is that it's all set up via code. Use this function to make a dialog, which is the box basically. With this, you just wrap a button in an if statement and you give it the width and the height, and then if somebody presses it, then it just returns true, and then you're able to do whatever you want. It's been a while since I have had to rely on code in order to make a graphical user interface, but I think it's pretty cool. However, I did run into one issue that gave me a lot of trouble. So if we look back at bridges and docks, you can remember that at the top of the screen, we had all those configurations and they were all sliders. And I really like that implementation because a slider is really intuitive and you can just drag values however you want, low or high. So when I actually went to the documentation to see how sliders are implemented, in this library, I was met with kind of an interesting discovery. Long story short, the API has changed since these docs were last updated, and it took me a while to figure out how to properly implement a slider because I was getting a bunch of errors when I was trying to use it. Luckily, I had joined the Lemonate Discord, and I was able to post my code snippet there and ask for help, and the developers were really active on there and responded and got me the right answer for how to properly utilize a slider in the project. And it was really cool to have public access to the developers of this game engine because I was able to rectify an error in their documentation and in the implementation of the code that I was working on almost immediately. With bigger game engines, you're not going to have that kind of access to people who want to help you. It felt like a very wholesome experience as a game developer, and I didn't feel like I was just at the whims of a big monolithic machine that couldn't care less about me. You can see I changed the default color because the black was just killing me, but I got this slider in and now it's working as it should, and you can click generate and it will come up with this nice little area of land that's procedurally generated, and then you can move the noise scale way up here. It looks gross because it's basically random. Now I also added in a camera controller so you can use WASD and move around a little bit now. So I added a couple more sliders in here. One is for the height, and then this one is really fun. I added scroll speed as a slider, and if you put it above 0, then it makes the land start to scroll, because then you actually get to start editing your terrain in real time. So I can make the noise scale a little more gradual. I can speed up the speed, and you can see that it's just scrolling along this path. And what it's doing behind the scenes is it's offsetting the X input for the Perlin noise algorithm, but it's utilizing the object pooling and just recycling a lot of these blocks. There's definitely some more changes that I want to make to this, but I think the scrolling feature actually adds a lot. Okay, so now I want to show you the final version of this project that I was able to make in this web-based game engine. So I'm really happy with how this turned out. I was able to do height-based colors for the blocks that spawn in. I was also able to add in some post-processing nodes, which is awesome. This literally was so easy to just spawn in new nodes. They have a whole bunch here that you can put in, and then you just drag and drop the connections. And so I was able to add a little bit of bloom, a little bit of an outline for each object, and then just drag that into the output, and I think it looks really good. So all in all, I'm really happy with this implementation. I think that it turned out looking really good, and I was impressed with how easy it was to get up and running in this game engine. I was expecting to have more sort of pain points as I was trying to figure out how to do things, but everything just kind of worked. This game engine was a lot of fun to use. I would recommend it if you're looking for something that's lightweight, something that is easy to get into, something that programmers would have a lot of fun with. I think this would be an awesome thing for you to try out. And if you do, I know from talking to the developers and the team over at Lemonate that they would really value your feedback. So use that feedback form, go to the Discord. I'll leave a link for their Discord. They would love to hear from more developers about how they can improve the engine. I think with it going open source soon, it's going to be getting a lot of traction within that community, and I'm excited to see where it goes from here. I'll have this project published on Lemonate's website, so if you want to go there and remix it and make it better yourself, that would be really cool. If you want to add in spawning trees, that would be a really cool challenge if you want to take this and kind of make it your own. Other than that, thanks again to Lemonate for sponsoring this video, and I'll see you all in the next one.